Welcome to the video. This video is about cross product of two vectors. More specifically, I will explain what is the meaning of cross product vector magnitude and the methods that can be used to determine its magnitude and how to find out its direction using right hand rule. So let's begin. Now coming to the meaning of the cross product vector, in order to explain that, let's consider a rectangular coordinate system with the two vectors vector A and vector B drawn from the origin. These two vectors form a parallelogram just like this. So it is a parallelogram. Therefore, the magnitude of cross product vector is the area of the parallelogram formed by these two vectors. That is, area of parallelogram is equal to magnitude of cross product vector. Now determining the direction of cross product vector. The direction can be found using right hand rule. It states that point your hand in the direction of vector A and then curl your fingers towards vector B. The direction in which the thumb points is the direction of cross product vector. Let me show you practically how right hand rule can be used to determine the direction. Both vectors positioned at coordinate system. If this is the first vector, then the direction will be out of the page. If this is the first vector, then direction will be into the page. Similarly, change the orientation. If this is the first vector, then the direction will be out of the page. And if this is the first vector, then the direction will be into the page. So that's how right hand rule can be used. Now the methods that can be used to find out its magnitude. This video will talk about two such methods. The method 1 is, consider two vectors A and B with theta as the angle between them. Given the magnitude of each vector and the angle between them, magnitude of cross product vector can be found out as C is equal to A cross B. So C magnitude will be equal to magnitude of vector A multiplied by magnitude of vector B multiplied by the sine of the angle between vector A and vector B. So that's how, using this formula, the magnitude of vector C can be determined. Here is the sine component of vector A and this is the sine component of vector B. In evaluating magnitude, either multiply the magnitude of vector A with the sine component of the magnitude of vector B, or multiply the magnitude of vector B with the sine component of the magnitude of vector A. Let's take an example to make things clear. Considering the problem below, two vectors A and B with theta as an angle between them. The value of theta here is 17.73. Magnitude of vector A is square root 66. Magnitude of vector B is square root 89. Plugging the values in a formula, magnitude of cross product vector comes out to be 23.34. So that's how first method can be used to determine the magnitude of cross product vector. Now the second method. The second method is based on determinant of vectors. The vectors must be in their component form. Consider the following steps to accurately apply this method. Step 1. Write vector A and vector B in their component form. Step 2. Write a 3 cross 3 determinant with first row as I, J, K, which are the unit vectors. Step 3. Write second row as the component of vector A, which is your first vector. Step 4. Write third row as the component of vector B, which is your second vector. And step 5. Evaluate the determinant. So let's take an example on this method. Consider two vectors, vector A and vector B in their component form. Write first row as I, J, K, second row as the component of vector A, and third row as the component of vector B. Now evaluating determinant by expanding row 1. Any row or column can be expanded, providing that you know the rules. If you want me to make a video about determinants and how they can be evaluated, kindly mention that in the comment section below. So expanding by row 1, So that's how you evaluate a determinant. Ignore this plus sign here. The cross product factor comes out to be C is equal to 22I plus 5J plus 6K. So its magnitude is 23.34, same as in method 1 because the same problem was solved using two methods. Thank you guys for watching this video. If the video helped you, like it and subscribe for more.